Have you ever pictured Earth as a perfect sphere? It's a common image, but it's not entirely accurate. Our planet is round, but it has a unique shape that's influenced by many factors. For centuries, people have been fascinated by Earth's shape and what it means. Ancient cultures had different beliefs, but the idea of a spherical Earth emerged through observation and exploration. Understanding Earth's true form is crucial for scientists and has real-world implications for things like navigation and communication. This exploration of Earth's shape promises to be an eye-opening journey. While we often visualize Earth as a perfect sphere, the reality is more complex. Our planet is slightly flattened at the poles and bulging at the equator. This shape, called an oblate spheroid, is primarily due to Earth's rotation. As Earth spins, the centrifugal force pushes outward, creating a bulge at the equator. Think of it like spinning dough, the edges expand outward. Similarly, Earth's rotation affects its shape. In the next scenes, we'll delve into the evidence that supports this understanding of our planet's form. In an age of scientific advancement, it might seem surprising that some people still believe the Earth is flat. This belief, known as the flat Earth theory, contradicts centuries of scientific evidence. Flat Earth proponents often claim that images of a spherical Earth are fake and that scientists are part of a global conspiracy. They present alternative explanations for phenomena like gravity and day and night cycles. However, these claims lack scientific rigor and are easily debunked by basic physics and observations. The evidence overwhelmingly supports a spherical Earth. Let's explore some of the most compelling evidence that refutes the flat Earth theory. One of the most striking pieces of evidence for Earth's roundness comes from space. When we look at the images captured by satellites and astronauts, we see a beautiful curved planet. These images are not just pretty pictures, they are scientific proof of Earth's shape. Satellites and astronauts have captured countless images of our planet, clearly showing its curvature. These images are taken from various angles and altitudes, providing a comprehensive view of our spherical world. From the International Space Station, orbiting about 250 miles above Earth, to satellites much farther out, the curvature is evident. These images are not computer-generated fakes, as some flat Earth proponents claim. They are the result of advanced technology and years of space exploration. The cameras on these satellites and spacecraft are designed to capture high-resolution images, providing us with a clear and accurate representation of our planet. They are real photographs taken from hundreds or even thousands of miles above Earth's surface. The clarity and detail in these images are astounding, showing everything from the vast oceans to the intricate patterns of cloud formations. These photographs are used by scientists to study weather patterns, track environmental changes, and even monitor natural disasters. Imagine looking out of a spaceship window and seeing the Earth below, a blue and green sphere against the blackness of space. This view is not just a dream, it is a reality for astronauts who have had the privilege of traveling to space. They describe the experience as life-changing, seeing our planet in its entirety, floating in the vastness of space. This is the reality that astronauts experience firsthand. They witness the curvature of the Earth with their own eyes, a sight that leaves a lasting impression. Many astronauts have shared their photos and stories, helping to educate and inspire people about the true nature of our planet. The visual evidence from space is undeniable and provides a powerful counter-argument to the flat Earth theory. These images and experiences from space serve as a reminder of the incredible advancements in science and technology that allow us to explore and understand our world. They reinforce the fact that Earth is a round, dynamic planet constantly changing and evolving. We don't need to go to space to see evidence of Earth's curvature. The clues are all around us, hidden in plain sight, waiting to be discovered by those who take the time to observe and understand. Simple observations from our own planet's surface can reveal its true shape. These observations have been made for centuries, long before the advent of modern technology. Mariners, astronomers, and even everyday people have all contributed to our understanding of Earth's form. For example, when ships sail away from the shore, they don't just get smaller and smaller. This phenomenon has been noted by sailors for hundreds of years. As a ship moves further away, it appears to sink, disappearing hull first. Instead, they disappear hull first, as if they are sinking below the horizon. This is a direct consequence of the Earth's curvature. The rounded surface of our planet causes the hull to vanish from view before the masts and sails. This happens because the Earth's curvature obscures the hull first, followed by the masts. It's a gradual process that can be observed with the naked eye, and it provides compelling evidence of a spherical Earth. If the Earth were flat, ships would simply get smaller and smaller until they were too far away to see. There would be no gradual disappearance of the hull, no sinking effect. The ship would remain fully visible, just shrinking in size. Similarly, the way airplanes fly around the globe and the changing positions of stars in the night sky all point to a spherical Earth. Pilots navigate using the curvature of the Earth, adjusting their routes to account for its round shape. The stars, too, tell a story. As we move across the surface of the Earth, different constellations come into view, while others disappear below the horizon. This movement of stars is due to our planet's rotation and its spherical shape. If the Earth were flat, we would see the same stars no matter where we traveled. But because our planet is a globe, the night sky changes as we move from one hemisphere to another. The North Star, for example, remains fixed in the sky for observers in the northern hemisphere, while other stars appear to rotate around it. This is another clue that we live on a rotating spherical planet. These observations, both ancient and modern, all point to the same conclusion. Earth is a sphere. From the way ships disappear over the horizon to the changing constellations in the night sky, the evidence is all around us. We just need to look and understand. So next time you gaze out at the ocean or look up at the stars, remember that you're witnessing the subtle clues of our planet's true shape. The sea and sky are full of secrets, waiting to be uncovered by curious minds. Gravity plays a crucial role in shaping our planet. It's the invisible force that governs the motion of celestial bodies and keeps our feet firmly planted on the ground. Without gravity, life as we know it would be impossible. It's the force that pulls all objects towards the center of the Earth. This fundamental force was famously illustrated by Sir Isaac Newton when he observed an apple falling from a tree. Newton's insight led to the formulation of the law of universal gravitation, which explains how every mass attracts every other mass. If Earth were a flat disk, gravity would pull everything towards the center of the disk. This would mean that the gravitational pull would not be uniform across the surface. The further you moved from the center, the more you would feel a sideways pull towards the center. This would create some strange effects. Imagine trying to walk on such a surface. It would be like constantly walking uphill or downhill depending on your location. Everyday activities would become incredibly challenging. For example, objects would roll uphill as they moved away from the center. This is because the gravitational force would be pulling them towards the center of the disk, creating an illusion of objects defying gravity as we understand it. However, we don't observe these effects in reality. Instead, we see objects falling straight down, no matter where we are on Earth. This consistency is a key indicator of the spherical nature of our planet. Gravity pulls everything towards Earth's center, which is why objects fall straight down, and we experience a consistent gravitational pull no matter where we are on the planet. This uniformity is crucial for maintaining the balance and stability of our environment. The way gravity works is only possible on a spherical Earth, providing further evidence for its shape. The curvature of the Earth ensures that gravity acts uniformly, pulling everything towards the center. This not only supports the spherical model, but also explains why we don't experience the bizarre gravitational anomalies that would occur on a flat Earth. In space, where gravity is much weaker, we can observe how objects behave differently. Astronauts float around in a state of microgravity, demonstrating the absence of a strong gravitational pull. This contrast highlights the importance of Earth's gravity in maintaining our daily lives. Gravity also plays a vital role in shaping Earth's landscapes. It influences the formation of mountains, the flow of rivers, and the stability of oceans. Without gravity, these natural features would not exist in their current form. From the simplest activities like walking and jumping to complex engineering projects, gravity is a constant force that we often take for granted. Understanding its role helps us appreciate the delicate balance that makes life on Earth possible. So the next time you look up at the sky or feel the ground beneath your feet, remember the incredible force of gravity that holds our world together. It's a fundamental aspect of our existence, shaping not just our planet, but the entire universe. We've established that Earth is round, but as mentioned earlier, it's not a perfect sphere. Earth is an oblate spheroid, meaning it's slightly flattened at the poles and bulging at the equator. This shape is caused by Earth's rotation. As Earth spins, the centrifugal force pushes outward, creating the equatorial bulge. The difference between Earth's equatorial and polar diameters is small, about 26 miles. However, this difference is significant enough to affect things like satellite orbits and GPS navigation. Understanding Earth's precise shape is essential for many scientific and technological applications. The debate about Earth's shape highlights the importance of critical thinking and relying on scientific evidence. While it's natural to question and explore different ideas, it's crucial to base our understanding on facts and observations. The evidence for a spherical Earth is overwhelming and comes from a variety of sources, including visual observations, physical laws, and scientific measurements. By embracing scientific inquiry and critical thinking, we can develop a more accurate and nuanced understanding of the world around us. The exploration of Earth's shape is just one example of how science helps us unravel the mysteries of the universe. From the smallest atoms to the largest galaxies, there's always something new to discover. So, keep asking questions, exploring new ideas, and seeking out scientific knowledge. The universe is full of wonders waiting to be uncovered. Thank you for joining me on this journey to understand our planet's unique shape. If you enjoyed this exploration, please subscribe to my channel for more fascinating insights into the cosmos.